Hello, this is William from Visual Components, and this is part 2 of the Basics of Working with Robots video series. In this video, you're going to learn how to connect a robot to other components using signals, how to perform grasp and release and tracing actions, as well as other RSL statements in the Teach tab. So I'll go to the Visual Components Webby Catalog, Generic Library, scroll down to the Robots folder, and add a robot to the 3D World origin. Let's go and turn the robot's envelope on, so I'll go to the Param tab, Workspace, and check the checkbox for envelope. So now I can see a visual representation of the robot's reachability in the 3D world. Go to the ECAT, and now let's go to the Conveyors folder, and go ahead and add a basic feeder. And now scroll down and add a sensor conveyor, position it within reach of the robot. Now add another sensor conveyor, and position it on the other side of the robot within reach, like so. Select the basic feeder and connect it to the sensor conveyor as shown. So now we have a basic layout set up. Voila! Alright, so we can go and turn the robot's reachability off its envelope. So let's go to Workspace, Envelope. There we go. Alright, now I want to connect the robot to the sensor conveyors. So what I can do is use PMP, select the robot, go to the dynamic toolbar and use this command here, connect signals. This opens a connection editor that basically uses all the signals in the robot that are available for inputting and outputting. So you can see in the editor I have the direction of the signal. In direction means the robot receives a signal, and then if I go and sort them by ID number, you can see I have an in and out direction where the robot sends out a signal. Now, by default, signals 1 through 16 are used for grasp and release actions. 17 through 32 are used for tracing, and signals 33 through 48 are used for mounting and dismounting of tools with the robot. Therefore, it's a good rule of thumb to use signals 50 and onwards when performing other actions. So what I'll go ahead and do now is I'll scroll down to signal 50, scrolling. Alright. And now I want to receive a signal from the sensor conveyor when a component arrives at its sensor. So what I can do is I can select the sensor conveyor here in the 3D world, or I can use the drop-down menu here. And I'll go and select in for signal 50, and I want to receive a sensor signal. So I'll select this one and click connect. And now in the connected column, I've indicated that the robot is connected to this component and this signal. So when the robot receives that signal, I want to send out a signal to the sensor conveyor to stop its path. So I'll use this signal here, connect. Alright, it's as easy as that. So how does this work? Well, make sure you remember these signal ID numbers. Close the editor, and now go to the Teach tab. So what I'll do is I'll create a wait for binary input statement in the robot's program. Notice I'm using the robot's main routine, and I'm going to wait for signal 50 to be true. Then I'm going to send out a signal using a set binary output statement, signal 50, to be false to stop the conveyor's path. Alright, so now let's go and see how this works. So I'm going to run the simulation. Components created, and bam, the robot stops the conveyor's path, like so. Pretty neat. So now what if I want to grasp that component and move it over to this conveyor here? Well, we can do that. So I'll go and show you now. Select the robot and go to the Param tab and the signal actions, and click this button here, configure. So by default, the robots in the library have an action script. So that means that pre-made signals are already set up for you for grasp, release, tracing, and mounting. So you can notice signal 1, when it's true, it grasps. When it's false, it releases. Same thing applies to tracing, so signal 17. When it's true, it traces on. When it's false, it traces off. For signals 33, when it's true, it mounts. When it's false, it unmounts. Okay? So what I can do now is I'll go back to the Teach tab, and I'll go ahead and snap the robot to a position over here. So I'll use Translate Tool, snap positions here in the dynamic toolbar, sorry. I'll use Snap on Face Centers and Snap on Orientation, because I want the robot to snap to the top of this cylinder here, like so. I'll create a grasp position. I'll lift up to be a retract or departure. Create a linear motion. Then I'll create a point-to-point motion statement, which will be the robot's approach point. So I'll move that to be at the beginning, its first position. So it goes there, grasps a component, and lifts it up. So let's go ahead and zoom out a bit. I'll reset, and now I'll run the simulation. Robot moves to the position. Alright, but it didn't grasp. What I need to do is I'll go to position 1. I'll create a set binary output statement. I'll use signal 1 and for value of true to grasp. So now I reset. Alright, there you go. So now the robot grasps. So what I want to do is I'll stop the simulation. I'll go over here to this sensor conveyor here. And what I'll do is I'll just jog the robot joints a bit. So now I want the robot to place this component on the conveyor's path. So what I'll do is I'll use translate tool, and I'll use translate along vector. So I'm going to go ahead and might be tricky to show, but I'll show you if I can. I'm going to snap the very bottom of that cylinder, like so, and now I'll snap the face center of the conveyor. So the robot basically just translated based on that distance or vector I created. Now let's go ahead and basically release the component to the conveyor. So I'll create a release point, retract, and this will be also my approach point for the robot when it goes to release the component. So I'll move that. There's position 2, and that'll be position 6. Alright, robot goes there, goes down. Now I need to release the component, so I'll create a set binary output statement. Use signal 1 and make it false. Okay, so now let's reset the simulation. The robot picks it up, moves over there. Let's get a better view. Hello. Alright, and there we have it. Great. Alright, and notice that the conveyor's path was moving already. So what I can do now is, what if I want to trace a robot's path from this conveyor over to this conveyor? So you notice point 2 is over here. So what I'll do now is I'll create a set binary output statement that uses signal 17. Let's see what happens now. Whoa, look at that, huh? Alright, so the robot basically traced its path from point 2 to position 6 over here. So now if I create another position for the robot, let's actually go to the end here, point 5. Use jog joints. Let's actually move the robot over here. Now I don't want the trace to be on when the robot moves from point 5 to point 7. So what I'll do is I'll select point 5, create a set binary output statement. I'll use signal 17, and I'll set it to false to turn the trace off. So now when I reset, hey, alright, everything worked out. And now what I want to do is use the call a subroutine statement. So notice I'm working in the main routine. I can create another sequence, or I can simply copy it. So I'll copy, and I'll paste. So notice when I pasted the main routine, I get a copy of the main routine here, and I get all of its statements as well. So I actually can go back to the main routine and delete all those statements. And now I can use this routine in the main routine by creating a call a subroutine statement. And then I reference it like that. So when I run the simulation, hey, everything worked out. Now I'm going to show you how you can loop a robot's program. So what I could do, notice in the main routine, is I'm calling a subroutine. Now you can do this over and over again, but that can get a little tedious. So what you can do is you can select the robot, go to the param tab, go to its executor, and make sure you turn on its looping parameter here by checking its checkbox. So that way when you run the simulation, the robot's program will loop. Now notice when you are moving to this position over here in the robot, you never turn the conveyor's path back on. So what we can do is we can stop the simulation, go to the copy of main routine, go to the end, and we'll create a set binary output statement for signal 50 to turn the conveyor path back on. So now when I reset the simulation and I run it, notice the robot is now looping its program, like so. Pretty cool, huh? Alright, solid gold. Now I'll go and show you how you can use some other RSL statements in the program. So I'll stop the simulation. I'll go and use a comment statement. So what I can do is I can position this here in the statement grid. So when a component arrives and the conveyor's path is stopped, I can write myself a little message saying, component has arrived, ready for pickup, like so. So now I'll go and clear my messages panel, move it up just a bit, reset, run the program. All right, notice I got my little message here. Yay! And I keep on getting the same message. All right. Now what I'll do is go ahead and create a halt statement, or delay statement, sorry. I'll create a delay. Move it to the end of the statement grid, and I'll create a delay from the robot looping its program. So I'll create a delay of 5 seconds. So I'll reset. Let's clear my message panel. Now notice the robot's initial state is kind of not what I want. So what I'll do is go to the Param tab, General, and I'll change its joint values. So 0, 0. Make this 90, 0, 0. Go to Simulation and save the state. So that's the robot's initial state in the simulation. Go back to the Teach tab. Run the simulation. All right, notice that there was that delay of 5 seconds. And there we go. Now let's go and use a halt statement. So I'll delete the delay statement and now create a halt statement. So let me show you what the difference is. So I'll run the simulation now. And what the halt statement does, it actually stops the simulation. So now I can trigger when I want the simulation to continue, like so. All right, so I can reset now. Now the halt statement actually comes with another property where it resets the simulation altogether. So if I check this checkbox, and now I run the simulation, all right, notice everything reset back to normal. All right, well that go ahead and concludes the video. If you have any more questions, please visit our community at community.visualcomponents.net and look forward to part 3 of the Basics of Working with Robots video series. Have a nice day.